Hello viewers, welcome to this video lecture. I am here to present its video lecture from chapter 3. Chapter 3 deals about the geometric designs of the highway. In the previous videos will be deals about the introduction about the geometric design of the highway, and also will be deals about the different elements of the geometric design, for example the horizontal alignment, vertical alignment, super elevation, fractions, and also will be deals about the sight distance, and also will be deals about the different design controls and criteria, for example the functional classification of the roads according to era manuals. Divide the roads with 5 major functional classifications. The first is a track road, second link road, access road, collector, and lastly will be a feeder roads. And also will be deals about the terrain depending upon Ethiopia Road Authority manuals. Will be also terrain will be classified as 4 major groups. The first is a flat. Mostly the slope is 0 up to 3%, and rolling from 3 up to 25%. Mountainous is 25 up to 15%, and greater than 15 is the terrain type is escarpment. And also will be deals about the design vehicles related to their physicals, as well as the dimensions, the widths, and the heights. Also deals about that. Today's will be deals about the design traffic volumes, and also will be deals about the design speed. The design traffic volume. So that we have deals about the traffic. We have collect information about the number of vehicles or the volume, and also the composition, how much vehicle passenger vehicles, how much minibuses, how much trucks, how much four-wheel drivers will be. The composition is very important. The design of the road should be based in parts on actual traffic volumes. The traffic indicates the need for improvements direct affect the features of the design, such as there is a number of traffic is higher, the width also will be affected, and the alignment, heavy vehicles, light vehicles on the alignment, vertical alignment as well as horizontal alignment, and also will be related to the gradient. The traffic data will be collected by in terms of annual average daily traffic, AADT, and the functional hierarchy is such a traffic aggregates as it moves from feeder to main collector to links, and lastly the track roads. So the track roads will be high number of traffic volume. Next to track it is a link, main collector, feeder is last parties. So the information will be collected all not only the traffic volume, it also will be considered as the traffic composition, and also will be traffic loads. It is very important for pavement design or structural design of the road. For example, this one is the functional class will be related to the design traffic volume. So for example, this will be this is era manual. Era manual will be there is design standard. The design standard is from 1 up to 10. The we are moving to DS1. The standard will be greater. The design speed is also will be greater. The quality or all will be DS1 is better. For example, will we classify the functional classification as a track road. Track roads include from D1 up to D5. So D1 will be 1000 up to 50,000. D2 will be 5,000 up to 10,000. So the track load is from design 1 up to design 5. Link roads will be design 2 up to design 8, and the main accesses will be D4 up to D10, and feeders also will be D7 up to D10. So this one is very important in considering the functional classification with the design speed. So the design speeds will be the 6 parts. The design speeds is very important. So the design vehicles is used as index that links road function, traffic flow, and terrains to the design parameter of side distance, as well as horizontal alignment to ensure that the driver is present with a reasonable constant speed environment. The design elements such as lane, shoulder width, horizontal alignment. So the for example, horizontal alignment, the design speed is higher, so the horizontal radius will be greater. The speed and the minimum radius will be directly proportional. Super elevation, side distances, and gradients are directly related with the design speed. In the geometric design parameters of the road is directly related to the design speed. Mostly the Ethiopian manual, the design speed is mostly influence the geometric design. Drivers on for example determine the following guidelines. Driver on long distance, for example it is a link road or track roads, there is the speed is higher speed than local traffics, and also the speed is related to the measure functions. For mobility purposes, it is majorly function is mobility. The speed is higher. The main function will be access. The speed will be decrease. Driver also will be the speed is related to the physical limitations. For example, the width will be very narrow, so the speed is also will be increased. The width of the lanes and also the number of lanes will be increased. The design speed also will be increased, and also will be considered as the economical considerations. Economical considerations, higher design speeds for high volume of traffics and less heavy traffic roads with similar topography. Changing in design speeds, so the design speeds will be related to the track. For example, there is a track will be a flat, the design speed is almost 120 kilometer per hour, and the when we changing from the flat to the rolling, the speed also will be decrease. So the speed changing speeds is related to changing the terrain. Important to notice that the design speeds of the vehicles is set at chosen speeds to ensure the safer design. The other one is the level of services. The level of services will be of the highway facilities influenced many factors, including the surface condition, rideable ability also will be related. From the standpoints of the design control, the level of service is principally related to the easy and convenient with the highway facilities, expected volume of the traffic. There is 6 type of level of service. It is from level A up to level 5. Level A with high level of service. Level of F will be low level of services. So in level A we'll have the road is level of service A. It is a free flow of traffic. There is unrestricted. The speed is unrestricted. It is we drive in selected desired speeds. In level 2 it is reasonably free traffic volumes. User able to select a desired speeds. The desired speed is unrestricted with a site delay in the freedoms. In level 3 stable flow, but the operation is users is significantly affected by the traffic, so the desired or selected speed will be decreased or restricted. Level 4 is the high density approaches unstable flow. So the density means the number of vehicles in a given road will be higher, so the speed and freedoms also will be restricted. When we coming to level of service E, it is operating near the capacity, high capacity with unstable flow, so the speed is very low. Freedom is extremely difficult or no freedom. Level of F is forced and breakdown flow. It is the traffic is exceeding the capacity of the road. The road is almost going and go, and also it is very congestion. The H is highway capacity. So the capacity is related to the maximum rates at which the peoples or vehicles reasonably be expected to traverse a point, such as a uniform section of lanes, roadways during a given time period under prevailing roadway and traffic condition. And designers will be generally the general conditions that may be warranted a detailed capacity analysis. For example, 2-lane roadway sections will be exceeding 114 passenger vehicles per hour totally in two-way. It is investigation is very important. More lanes or other capacity improvements will be necessary. The capacity of 2-lane roads is greatly reduced where there is a limited opportunity for passing slow moving vehicles. And also the capacity of 2-lane roads is significantly affected by long steep grades for slow moving trucks, and auxiliary or clamping lane is warranted. And also the lack of shoulders affects the vehicle speed, indirectly leads to decrease in capacity. We have provide shoulder, it is the speeds will be increase, so the capacity also will be increase. Intersections signalization and frequently may change capacity or require additional lanes. So mostly in Ethiopia the roundabouts will be changes with the signals for increasing the capacity of the intersections. The other is pedestrian. Pedestrian are one of important part of roadway environment. Pedestrian facility include sidewalks, traffic control features, refuge islands, curb cutting, ramp for old walkers and people with mobility impairment. And also the pedestrian actions are less predictable than those of the motoristics. It is difficult for design facility for safety. Orderly movement of a pedestrian is very less predictable. Pedestrian tends to focus on the paths that represent the shorter distance between the 2 pointers, and also will be the geometric design embrace the uh, bicycle facilities. Bicycle users are important element when making decision defining a project's design parameters. Major existing streets and highway systems can accommodate a bicycle without significant affect the cost and other impacts. So in existing roads, so improvements that be enhanced related to safety, promote increasing bicycle users by paving shoulder wider outside the traffic lanes, bicycle safety drains, adjust manholes and utility covers, maintenance smooth clear riding surfaces. This will be improve the bicycle facility. It is very safe. And also considering an economics, the economical roads will be more decide with alignment, the horizontal alignment, vertical alignment, the grades and the widths, the slopes, the speeds, all are influencing the construction costs. We have using the standards, more standardized, the cost will be increase. The geometrics and structural standard sets higher than need for a particular type of facility may cause increased expenditures that might be better spent on improving additional road sections. We have increasing the geometric as well as the structural standards. The standard established by the department flexes most judgments as to design criteria, particular conditions. Sometimes the standard will be expressed as a minimum value. For example, radius is a minimum value of radius for horizontal curves, minimum value for stopping side distance also will be related to this one. Designers should recognize this opportunity for increasing the cost of for high standards cannot be justified. And also will be deals about the safety. Safety is a major control in roadway design. The design should minimize driver decisions and reduce unexpected situations. So the driver safety involves a variety of factors involving. The first is the number and use of access points will be increased. The safety also will be decrease. Operating speed is also very important. We are always we are driving with the design speed. Type and width of the media. There is a media, there is more safeties. Shoulder widths. Alignment is very important. It is horizontal as well as vertical alignment. In horizontal alignment, the horizontal curves will be greater than the minimum radius. More it is sharp, the safety will be decreased. And also will be the deals about the vertical alignment. The alignment will be more steeper. There is decreasing safety. Roadside designers also will be very important. Uniform and proper application of traffic control devices, it is very important. So this one is traffic controls will be, it is provide communication between the designer and the driver. So signals will be provide, signs also will be provide, and road marking will be properly provide. And safety is related to the design intersections. Establish a standard generally considers safety factors such as minimum side distance, limitations on minimum curvatures on horizontal alignment for a particular design speeds are generally accepted as a minimum fixed value. So every horizontal curves as well as the side distances is greater than the minimum values. A safety also related with guard rails, shoulder widths, side slopes, lateral clearance also will be very important to a safety to maximizing a possibility of safety where it is necessary. And also designers should wait for opportunity to improve safety in the design with a little or no additional cost is involved. And also the speed is very related to the safety. So increasing safety above the design speeds, there is the outcome is accident. So we have drive less than the design speed. The safety speed is depending upon the design features, traffic volumes, weather conditions. Weather conditions means in dry conditions the design speeds will be greater. In wet conditions, the probability of the vehicles sliding is very greater, so decrease speeds. Spacing of intersection roads, cross traffic volumes, and other factors will be related. So vehicles design features that reduce the variance in speeds of vehicles, the change in lengths, shoulders, gradients, separations, appropriate signals and signs improving the highway safeties. The use of medians also increase safety in four-lane facilities, and also improving in alignment, horizontal alignment, vertical alignment, cross sections, including in the design. Roadside design itself is a very important tool for safety. Thank you for listening my video lecture. In the next video will be deals about the highway cross-sectional elements.